discuss Venderwals equation for state. We know that in kinetic theory, kinetic tells that there is no molecular volume. That means the kinetic theory already has neglected the molecular volume. It tells that the volume occupied by the molecule is so small that in comparison to total volume occupied by the gas, very small. Hence, the molecular volume can be neglected. The kinetic theory of gases has neglected the molecular volume. Similarly, in next postulate, kinetic tells that there is no intermolecular force of attraction in between the gas molecule. There is no intermolecular force of attraction in between the gas molecules. These are two important postulates of kinetic theory regarding molecular volume as well as intermolecular force of attraction, which has been modified by the scientist J.D. Venderwals due to the deviation between ideal gas and real gas equation. We know that ideal gas equation is equal to PV is equal to nRT. PV is equal to nRT. The ideal gases, those obey the ideal gas equation under all conditions of temperature and pressure are said to be ideal gas. But ideal gas is a hypothetical phenomenon. Real gas, the gases those obey the gas equation PV generality under all conditions of temperature and pressure are said to be real gas. But practically it is found that no gas is ideal. No gas is ideal. At high temperature and low pressure, the real gases behave ideally. And this is the deviation. Between real gas and the ideal gas. The scientist J.D. Venderwals modified the ideal gas equation PV is equal to nRT into P plus N A by V square V minus NB is equal to nRT, taking into molecular volume and intermolecular force of attraction into consideration. Taking into intermolecular force of attraction as well as molecular volume into consideration. He modified the ideal gas equation PV is equal to nRT into P plus N A by V square whole into V minus NB is equal to nRT by taking into molecular volume and intermolecular force of attraction into consideration. Let us discuss the volume correction. First, we discuss the volume correction. We know that the molecules are spherical in nature. And hence the volume, if R is equal to radius of the sphere, then volume is equal to 4 by 3 pi r cube. It is a very simple mathematical formula. The volume of the sphere is equal to 4 by 3 pi r cube if R is equal to radius of the molecule. And molecule treated as a spherical in nature. And if R is the radius, the volume of sphere is equal to 4 by 3 pi r cube. When gas occupies large space, the molecules are far away from each other. When gas occupies large space, the molecules are far away from each other. Therefore, under that condition, the molecular volume has no importance. That is, the volume of entire gas takes importance. The molecule of individual molecule has no importance. When the gas is subjected to high pressure, the molecules are come closer, and that is the molecule come the closest as possible. And under this condition, the molecular volume takes importance and molecular volume cannot be neglected. Under this condition, molecular volume cannot be neglected. In this condition, we have to consider the molecular volume. Let us consider the closest approach of two molecules. That is, the molecules are closest approach. body of one molecule touches the body of another molecule. This is called the closest approach of two molecules. If r is radius of sphere of one molecule, then radius of the total radius is equal to 2r. 2r is radius of sphere. Then volume occupied by closest approach two molecule is equal to 4 by 3 pi 2r cube. That means 4 by 3 pi 8r cube. This is the volume of closest approach of two molecules. Volume the closest approach of two molecules. This is the volume of the closest approach of two molecules. When two molecules come closest, then this is the volume occupied by two molecules. This is the closest approach volume for two molecules. Now we calculate the closest approach volume for one molecule. That means we will divide the volume by 2. That means 2. Then this is the 4 divided by 2. Then closest volume for one molecule is equal to 4 into 4 by 3 pi r cube. 4 into 4 by 3 pi r cube. That is 4 by 3 pi r cube is equal to actual volume one molecule. Then that means the closest approach volume of one molecule is 4 times the actual volume occupied by one molecule. The closest approach volume for one molecule is 4 times the actual volume occupied by molecule. You consider how large it is that we have neglected in the kinetic theory. Very large. The closest approach molecule is 4 times actual volume occupied by molecule, which have been neglected in the kinetic theory. And this is depended by a constant B, because 4 is constant, 4 by 3 constant, R is radius of a molecule for a particular gas molecule, R is also constant. Therefore, the closest approach molecule is treated as a constant B and is constant for a particular gas. Then in ideal volume, which is completely compressible, we have, in order to get the ideal volume, we have to deduce the molecular volume from the observed volume. In order to get the ideal volume, which is completely compressible, in order to get the completely compressible part, we have to deduce the incompressible part. The incompressible part is the actual volume of the molecule. See, the incompressible, it cannot be compressed. Therefore, in order to get the ideal volume, which is completely compressible, we have to deduce the molecular volume from the observed volume of the gas. That means VI, that means V ideal volume, VO minus B. VO is equal to, VO stands for observed volume of the gas. That is means the volume occupied by gas, and B is the molecular volume. Then if there is n mole of the gas, then VI, that means ideal volume, is equal to V observed volume minus NB for n mole. That means volume, correct volume is ideal volume is equal to VO minus NB. NB. B is the actual volume of the molecule. Then ideal volume is equal to VI is equal to V0 minus NB. This is the true volume we have to use in all purposes. This volume correction was made by scientist Venderwals. This is the considering the closest, it has been calculated by considering the closest approach of two molecules. Under what condition the molecular volume takes most importance? Under this condition the molecular volume takes much importance, and hence in this condition we cannot neglect molecular volume. And it is found from the calculation that this closest approach volume, that means when the molecules are come closer and touch each other, at that condition the closest approach volume for one molecule is equal to 4 times the actual volume of the molecule, which has been neglected by the kinetic theory, and Venderwals corrected the ideal volume by deducing the actual volume of the molecule from the observed volume, because ideal volume is, according to kinetic theory, is compressible. In order to get the compressible part, we have to deduce, or we have to minus the incompressible part from the observed volume. Therefore, V ideal volume equal V observed volume minus incompressible volume, that is molecular volume, is V. This is the volume correction. Thanks.